Today we're going to look at De Moivre's theorem. So De Moivre's theorem is a special theorem that relates to what we've just learnt in the last video on mod arg form, and it allows us to very quickly raise a complex number to a high power. So De Moivre's theorem tells us that if we've got in mod arg form r cos theta plus I sine theta, then z to the n is just r to the n, so we raise the modulus to the power, and then we just times the angle by that power. In our actual class, I'm going to prove De Moivre's theorem for you, and we're also going to prove it later when we do mathematical or further mathematical induction. But for now, we're just going to apply De Moivre's theorem in this video. So raising to the power of 5, we raise the modulus to the power of 5, and we multiply the arguments by 5. And this is what De Moivre's theorem tells us. So 2 to the power of 5 is 32 cos of 3 pi on 2 plus I sine 3 pi on 2. Now, cos of 3 pi on 2 is negative 1, and sine of 3 pi on 2 is 0, so we get negative 32. Now, we can use De Moivre's theorem to apply it to questions that are in Cartesian form, but to actually do that, we need to first convert this to mod arg form. And in fact, raising complex numbers to high powers, it's a lot of the time much easier to first of all convert it to mod arg form. So we draw a quick diagram. We've got a real component of root 3 and an imaginary component of 1. And if we do tan inverse of that, theta is tan inverse of 1 on root 3. We get pi on 6. And the modulus of that, mod z, is the square root of 1 squared plus root 3 squared, which is 4, so the square root of 4 is 2. So our original question, root 3 plus I to the power of 6, is the same as 2 cos pi on 6 plus I sine pi on 6. And if we raise that to the power of 6, we've got 2 to the power of 6 outside of cos of pi on 6 times 6 plus I sine of pi on 6 times 6. And of course, pi on 6 times 6, 2 to the power of 6 is 64. Well, pi on 6 times 6 is pi, and cos of pi is negative 1. And then sine of pi on 6 is the same, pi on 6 times 6 is the same as sine of pi, which is 0. The answer is negative 64. Of course, in class we're going to get into some more complex examples, but that there is the basis of De Moivre's theorem, and it allows us to quickly expand complex numbers raised to higher powers. Thank you.